Hi everyone. Thank you for coming. Welcome to our session, Technical Writing at SUSE, a cherry-picking peek behind the scenes. Cherry-picking in quotes, we'll come to that a bit later. I'm John Krug and this is Frank Sundermeyer, and we work in technical documentation at SUSE. That's me there. Just there, that's me, yes. Okay. Right, so these are the things we're going to be looking at. Information architecture. Frank's going to talk about SEO. I'm going to look at diagramming as code, some about regular expressions, English in the international technical audience. And these are things that I've been at SUSE a year now, and these are some of the things I've done and some of the interesting ideas I've come across in the past year, and I want to talk a little bit about them. And then Frank's going to talk about documentation analytics, a bit time for a wrap-up and some questions. Okay. So we've got a few underlying themes. We work on different teams, but we're trying to work closely together. We're always concerned with the customer, our audience, our documentation. It's really all about getting you to be able to use our products effectively. So we prefer open source. We work at SUSE. We're documenting engineering products in most cases, sometimes about how they work, sometimes how to use them, how to install them, uninstall them, all the sort of things that you might do with some of our products. And a little bit about engineering documentation as well. So by that I mean all the tools that we need to be able to construct a good documentation resource for you. It's conceptually the least important part of our work, but we spend an awful lot of time doing it because we want to give you something that's looks good, basically. So the tool chain is often largely to do with giving you something that's usable and looks great. Right, so I'll hand over to Frank for a bit, and he's going to talk about SEO. And there you go.
Yeah, SEO is all about findability and visibility. So if we hopefully write the best documentation for you, but it would be of no use if you can't find it. And here SEO comes in a really important thing because let's be honest, what do you do when you have a question? You fire up Google and then you expect to find our documentation, which in fact was not always the case. I think we have done a pretty good job in the last 2 years by taking care of SEO. Because SEO guarantees that you find what is relevant for you. It's trustworthy, so you get the documentation that best answers your question. It's about accessibility. You expect our documentation to be on page 1 of the Google results. And that, in fact, gives you a great user experience. This may sound trivial, but it's not that easy to achieve that. The SEO topic is pretty complicated, and it starts actually with constantly monitoring the SEO performance, because it's not a given that a page that has got a good score will keep that score. It's an ongoing process. You constantly have to adjust to new technologies, new stuff that Google wants to be in those pages. So this is really an ongoing effort. One of the things that we do is we keep track of what you enter in the search engine and where you find SUSE articles, and from that we derive a keyword database to make sure that those keywords that you are searching for appear in our articles. And also equally important is Google, and it's mainly Google that keeps an eye on SEO. Wants articles to be structured in a certain way that goes back to the information architecture thing. This also forces us to produce documentation that has a good structure and is easy to understand. And another important aspect is actually performance. This is one of the most important aspects in SEO. So Google measures performance, and sites that take long to load are ranked lower than good performing sites. So what you can see here is some of the aspects I've been talking about in graphics. So here you can see mobility performance of documentation SUSE.com over time. What you can also see here is history of keywords. We can see popularity of certain keywords, or in this case, keyword families. We can monitor them and make sure that these keywords turn up. And we are also, those two graphics stem from Google tools that we are using. This is a lighthouse analysis where we can measure overall SEO performance, site performance, loading, accessibility issues, and some best practices. This is structure, whether you're using HTTPS and that kind of stuff. So overall, although it sounds trivial, making this happen takes quite a bit of effort from our side, and yeah, hopefully gives you good search results. With that, I'm handing back over to John.
Okay. Thank you, Frank. Okay, diagrams as code. So our teams are proponents of documentation of code, and for many good reasons. We want a documentation development process that's somewhat in sync with what our product developers are using. So we are talking about maintainability, automation, continuous integration. We want to be able to track changes the same as you do in source code. We want to be able to track those changes in the same way in documentation. We want a joint production process of the documentation between the documentation team and the developers. The developers are the source of truth for the documentation, and in some respects you could say that we're polishing it and making it really fit for the purpose of making our products usable. So those joint tools, plain text editors, VS Code or Emacs, Vibe, whatever your particular religion happens to be, GitHub and GitLab, and those sort of code control, code management tools. And so we didn't want diagramming to exist as something completely separate to this. Traditionally, if you're asked to produce an architecture diagram, you would fire up something like Inkscape, which is great graphical editor. It's quite a learning curve. There's an awful lot to it. You need to learn plenty to be able to make really effective use of it. So we were interested in something that our developers wouldn't need to learn a graphical tool like Inkscape or many of the others. Want something that was a little more familiar to them. So these textual code descriptions of a language, wide from general purpose diagramming to stuff that's very domain specific, comes in flavors. At the moment we are using Docusaurus, and that integrates Mermaid quite nicely. Mermaid's a great descriptive language for a diagram. Looks like a programming language. Again, it's fitting in nicely with how we want to work with our developers. There are others, GraphViz, PlantUML. It's a developing area. They're starting to see some specific languages geared towards producing solely architecture diagrams for the cloud and the internet age. Structurizer being the main one at the moment that I'm aware of. So I inherited the documentation for a project called CubeWarden, and this diagram was done maybe 4 years ago. What existed was a PNG file, and there was an SVG file as well. Okay, now SVG is a text format, but it's a graphical page layout language. It's not really about describing some architectural concepts in more of a programmatic way. So we wanted to choose something, and we ended up with Mermaid because it fitted our needs and fitted with the current set of tools. Right, and doing this way, you fit in automatically with free use of editors and being able to use GitHub and Git and all those familiar tools that are familiar for ourselves and the developers. And we need to pay attention to the consumers these days. A translation tool has a pretty difficult time with a PNG or an SVG file, but it can maybe work a little bit better with something that's more like a program description. And especially these days, AI is certainly going to be able to make better sense of a program than it can do of a PNG or other graphical format. Okay, so what does it look like? So this is the diagram that CubeWarden architecture. The CubeWarden architecture was originally described in. It became clear that it was no longer actually describing the architecture, and there was all sorts of things that were concerning, like Kubernetes control plane and Kubernetes data plane. Why were they in there? Were they relevant to the architectural description of CubeWarden? And this is the Mermaid code that describes this diagram down the bottom, which is what's come to replace it. You can see it's exactly like a program. There are subroutines or subgraphs which are describing various components in the diagram and building them up into blocks of architecture, if you like, for want of a better word. And we have connections between things. So this CubeWarden controller creates a policy server instance, and that is stored in the policy server and the OCI registry, and that's a straightforward description. So the straightforward description down here. An audit scanner sends audit admission requests to the policy server. So you can see that one there sends audit admission requests. So it's quite a natural way of a programmer to approach doing some documentation that fits in really nicely with the whole documentation as code setup. So that's been quite successful for us, architecture diagram, and we do things like upgrade paths, so you can go from version 5.1 to 5.2, but not to 5.6, and that sort of thing it's pretty good at as well. Okay, all right. So that was one of the interesting things I've done over the past year. The other one, I got a large documentation set for a product called Longhorn, and it's currently rendered, this documentation set, using Hugo, static site generator, and we needed to migrate it to a different static site generator, Docusaurus. And this documentation set is peppered with these things. So current version is referred everywhere. It's in path names, it's in general textual description for the Longhorn product, and this works in Hugo. It's a kind of handlebars construct templating language. When Hugo runs against the Markdown documentation set, it finds all these current versions. It looks at the path where it is, works out that it's version 1.6.1 that it's talking about, and replaces in that page all instances of current version with 1.6.1. So now Docusaurus doesn't have this. So I needed a way of being able to identify. I could do some JavaScript, but I needed then to get the path and the version number out of the path, and then replace all of these with that version number. Okay, the other problem, again, this handlebar templating type of thing, it describes, there's a picture going here and you get it from f.png and it's got some alt text. Okay, so that's how, one of the ways. It's not the exclusive way in which Hugo describes to put a picture on the page. Docusaurus, completely different. It's the standard Markdown representation of a picture. So there are thousands of these in the documentation set, and thousands, well, hundreds of these images. So trying to go through all of that, edit it by hand, very error-prone process. You know, miss a space, and it's all going to go quite wrong. So, bit of a history lesson about regular expressions. From the 1950s, Stephen Klein's a mathematician, and he came up with this idea of regular language, and a regular language is described by a regular expression. Late 60s and 70s, further developed by Ken Thompson, who worked at Bell Labs, and you may remember his name. He's along with Dennis Ritchie, he's the inventor of Unix, and from which comes Linux, and we're all working on that today. 80s and 90s, Perl and TCL, leading up to Perl compatible regular expressions, which most languages have libraries for. And I just wanted to talk a little bit about the history to give a sense of the academic origins of this stuff and the open source story. This source code leaked out of Bell Labs, more or less, and was developed. And at SUSE today, and I think DP is going to talk about it in one of the keynote addresses, we're very keen on this open source story and continuing with that. So, regular expressions, how did we do it? Right. So this is the regular expression. It looks a bit like something transmission line noise printed out, but I'm looking for the version here, and then I'm going to capture this 1.61 in this capture group version number variable name, and these characters describe the format of this 1.61 or 1.6.1.2 or whatever. And so in a in a Perl program, I think it was, no, Python program I did it with in the end, it loops through this, it finds everything that matches it, it gets the version number and it replaces it with the 1.6.1, that current version string that we saw earlier. This one, again, similar sort of thing. We're looking for looking for these constructs and getting getting the path name and the alt text into these variables, and then again, in a little Python program that runs in a loop, it can replace every instance of this with that. And it's something that's pretty near impossible to do without some level of automation, and regular expressions are the perfect way to do it. Okay, right. Last slide for me. I just wanted to talk a little bit about English for international technical audiences, which I've come across. The problem is international clarity. We want people to be able to use our products, and English is the language in which we describe the products. There's some translation going on, but mainly it's in English. And whether it's in your own language or as you're learning English, you're encouraged to use idiomatic language because it adds richness and depth to a language, and you're encouraged to use it to show that you appreciate these nuances of the language, and to show a level of proficiency, whether you're learning a language or a native speaker of the language. But you're doing documentation for people who English could well be a second language, and we want to make that documentation very clear for them as well. And over the past year, I've found all of these examples, most of these examples in my engineers' blog posts and technical documentation. And even people who speak English from America and Britain will have widely different understanding. So looking under the hood, for example, Hollywood films over the years have taught us that looking under the hood means to look under the look into the engine to see what's going on. But in United Kingdom English, you talk about a bonnet for a car, not a hood. So without that Hollywood background, nobody from the UK would know what looking under the hood means, or would think it's strange looking under the hood, the hoodie, or and similarly, somebody from America thinking looking under the bonnet, it's one of those frilly hats or something, isn't it? So glossing over the details, well, you see that a lot. But what does it really mean? So you need to understand that gloss is a sort of paint, and you're painting over the details to hide them, but you're doing it with gloss, which is nice and shiny, so you're kind of glossing over the details to hide some sort of ugliness there. And is that really what you meant to say? Possibly not. Sketching out a solution, need to understand what a sketch is. The next two from British naval in the 1800s. So you need a lot of context for some of these idioms to be able to fully understand and appreciate them, and what the author is trying to convey to you when using them. So we'd prefer that, like the ship of Theseus, that you didn't necessarily need a philosophical background or background in classical Greek to be able to understand what somebody's saying in our documentation. Cherry picking, what this talk is about. So idiomatic phrasing is cool, but hold your horses. If you look it up online, you'll see various explanations about where this term comes from. Pulling canal boats perhaps along the Erie Canal, or but I think the earliest recorded use of it is by a Roman historian who was talking about chariot races. But to understand that hold your horses means steady on, just wait a minute, take a moment. You need a lot of cultural background and understanding, which as a second, if English is not your main language, then you'd have difficulty. So we don't want to see this sort of stuff in documentation, really. And with that, thank you. I'll hand over to Frank again.
Okay, yeah, the last piece we wanted to talk about today is again some data related. That is documentation analytics. You know, everyone is doing analytics. We do that as well. We want really to make sure to produce the documentation that you need, and therefore we need to know a few things about you, starting with topics that are relevant. So again, something I mentioned before, we are monitoring keywords that you are searching for. We are monitoring which articles or which documents are top performers, which are low performers. So everything that is on top of the request list gets more attention, because apparently it's something that you often need and where you often look into. We also do some cross-references with support, for example, to see which topics are on top of the list of support requests, and try to handle those in documentation to enable you to self-service solutions for problems. So we're doing constant improvements on the documentation, like with the SEO. It's an ongoing process. It's not only that the software develops and changes. It's also that in a first draft of a topic, we may not have covered everything that you are interested in, and learning what else we can document so that you get the full picture is something that we do with analytics. Also, if there's bugs in our software, you may have seen that underneath every headline, we have a link that goes to Bugzilla where you can easily report bugs. This is feedback that's very valuable for us. We may not be able to fix everything within a couple of days. Sometimes it takes a bit longer, because all in all, for the SUSE Linux family of products, we currently maintain 12,000 pages of current documentation plus 25,000 of pages of documentation for products that are in maintenance. So that's quite a lot of stuff that we are producing. But rest assured, your bugs won't be forgotten, and we'll try to fix them as soon as possible. And again, this is something where we are using Google for to find UI issues in tracking where you click, which UI elements work, which may not work, just to give you the best experience on our website. And last but not least, localization. We haven't localized everything in all languages, because again, this is something where we try to find out via analytics what is most relevant to you, what is most relevant to certain countries. It's different in Asia Pacific, for example. English is not that common as it is in Europe, so it's really important to have more localization for the Japanese audience than, and that was something I really found astonishing, than for the French customers, because people in France mostly read our English documentation, even when it is available in French. So this is something we use for decision making. So what do we use for collecting data? As with SEO, we monitor performance using Google Analytics. We can see how our pages perform. We can see what you are searching for. So this is really important information. we identify the pain points by looking for stuff you search for that is not yet covered in documentation, but also monitor, as I said before, support requests and bugs you send to us. Same goes for UI and UX issues using Clarity. That's a Microsoft tool where we can see, for example, browse depth on a page, and then the longer an article is, the less people go to the bottom. So lesson learned, we need to shorten our documentation, which is something that we actually plan to do. And as I explained before, the localization stuff. And real life examples is we conduct a yearly documentation survey, which the new one actually starts with SUSECon. So in the tech showcase area, we have a booth. If you want to be one of the first ones giving us feedback, feel free to visit us at the booth. We have got a few tablets where you can fill out the documentation survey. Will take like 15 minutes. This is really a valuable source of information for us. You have the chance to rate our documentation, to let us know what is missing, and this is one of the most important sources of data that we have, because it comes directly from you. As I said before, tracking keywords and queries, monitoring content performance, and cross-referencing with support, with consultants, with salespeople, sometimes with our technology partners. So with IBM, for example, we have a close collaboration. They regularly read our Z-Series documentation before we publish them, and give us feedback on that. And as I said before, monitoring content performance in different countries. So here's two examples of what the data looks like. So this one is stats about in which geographic areas our documentation is used most, and this one is an example of cross-referencing with the support. Here you can see most popular support requests from a certain month. I don't know exactly which month that was. I think 3 months ago. Okay, so in summary, what we wanted to show you is, if you had the impression that tech writing is just firing up some sort of writing program and just start writing, it's a lot more than that. So, and then what we didn't even mention here is research, which takes about 50 to 70% of our time when we write documentation. So it's more than just writing. It's this SEO issue just to make sure you actually find our documentation. It's maintainability and automation. So our complete tool chain is structured in a way that we produce docs as code. This is the moniker under which most tech documentation is currently done. So we are not using text processors. We're producing source code. In John's team, it's Markdown. In my team, it's ASCII doc or DocBook XML. So really source code, which then is processed to produce HTML, PDF, single HTML, EPUB, you name it. And all of these steps are completely automated. So our tool chain checks out the sources from GitHub, validates them, builds them, and automatically publishes them. So we usually do regular updates every Thursday. It's just starting a script, and once that is finished and the docs are available on our staging server, we have a look to just ensure that everything is okay, and then it's just syncing it to the web server. So really completely automated. The other benefit, and that is what John mentioned, this docs as codes approach enables our engineers to actively participate in documentation, because we are exactly using the same workflows they do. We are using the same tools they do. Starts with editors. I mean, nowadays a lot of people are using VS Code. The old timers like me, I'm using Emacs or VI, but that's exactly the same stuff the developers use. GitHub, review processes in GitHub, automated publishing. Same is true for our packages in the build service. And then the documentation can even be completely built in the in the open build service of SUSE. So there's really a lot behind this docs as code thing. Yeah, in a nutshell, don't beat around the bush, keep things crystal clear. No, that's not what we want to say. It's clarity. It's use of simple and concise language, because as John explained, we are writing for people where English is not their first language, so it's important that people understand. And the second aspect of that is it actually also makes localization cheaper. So in school we learned when you have a list of things, start every list item with a different introduction because it sounds better. No, we are not doing this. If we have a list of items where you need to do something, every list item probably starts with do this, do this, do this, do this. It makes reading a lot more efficient, and your mind actually really anticipates that this is the next to-do item, and it makes localization cheaper. And last but not least, using your feedback, using monitoring your habits, anonymized, of course, because we are not interested in seeing what a certain user does. We just want to get a general picture of what our customers and users do in order to be able to improve the documentation. Okay, with this, before we come to any questions, I would like to announce a few sessions that we have in parallel to this session. There's another session about contributing to documentation. All in all, we have got 5 sessions, continuous in, correct me if I'm wrong, room 10, John, with the next talk about how to write technical documentation that actually works. And Nuno, your talk is then? Room 6. And last but not least, I'm going to show everyone who's interested a sneak peek into the new documentation portal that we plan to launch in September. We set up a POC, especially for SUSECon. You can also have a closer look at everything and have personal discussions with us at the SUSE demo kiosk in the tech showcase room. If you come in, it's in the middle, in the last row. So feel free to visit us, talk to us, and yeah. Also participate in the documentation survey if you want to. That's it. Any questions from your side? Apparently not. Then I say thank you for being a kind audience. And yeah, hope to talk to you in person at the demo booth or see you in one of our next talks. And yeah, that was the kick-off for you, very first session. So have a nice SUSECon, enjoy your stay here, and enjoy further sessions.